So, yeah. So, scientists across the road means accessible. Okay. So, whether I'm not a neighbor to your institute or not, you can always reach me. I'm a climate scientist working at IITM, Indian Institute of Tropical Meteorology. It's a government institution. It's also a sister institute of Indian Meteorological Department. We work under the same ministry, Ministry of Earth Sciences. We have about 150 scientists working solely on the monsoon. Yeah. And I'm one such a scientist, but I also look into climate change aspects of monsoon and whatever is changing in the larger Indo-Pacific region. Yeah. And one of the one of the key questions that Pankaj put in his first talk was, what is the motive of citizens science networks, right? And the story I'm putting forth to you here is that citizen science networks can save lives. Yeah. And this is from our experience during the last few years of citizen science network itself. So as a government scientist, I can be an armchair scientist. I can sit at my chair and it's quite easy, just to come, have some tea and go back. But this is something that has given me immense satisfaction. I connect with the society, connect with the people, and so on. It's and saving lives as well. So it gives a Superman like that feeling, yeah, inside you, other than just being an armchair scientist. So I just have one slide, but it talks a lot of stories I might miss. So I might get back to my notes here. So the first image here, you can see obviously it's a map of India, but there are some colors here, blue and red colors, and the red colors are more, kind of jarring and looking at you. Those colors shows regions where extreme rainfall events are increasing across India. Yeah. So a lot of parts of west and northwest, so Western Ghats region, some parts you can see it's increasing across central India, parts of northeast, including the Kashiranga and all where we talked about. Yeah. And this is going over, this is data over 70 plus years from IMD. So if you look at IMD, actually, since British times or since 1870s, it has been collecting data over different regions. So we have 150 years plus data, out of which since 1900, the weather data, particularly rainfall data, is on a daily scale. Yeah, on a daily scale, data is there with the IMD. And this map that we show here is based on that data. Yeah. Now, how can citizen science networks help? Yeah. Once we understand this, what is the role of, particularly we saw in the morning itself, at least, I think there were 3 presentations based on Abhijit Gandhi's work, Bhabdal's work, and Meghdou's work. Yeah, a lot of people focusing on rainfall. It means that there is huge variability in rainfall. Yeah, so even if you see a large spot here within that area itself, the rainfall variability might not be in phase. There are large regional variabilities which we need to understand, and it's connected with a lot of other factors as well. So personally, my hometown also is from this region, and there happened to be a river protection council like what Jeevat Nadi is. So that's called the Minichil River Protection Council. It has been in existence for the last 30 plus years, since early 1990s. Yeah, more of an environment group at that time. But around 2017, they understood that, okay, the rainfall is changing, monsoon is changing, a lot of other human interventions are also happening, and this degrading the river and the life quality around that region, and also putting citizens in peril. So they started monitoring data, and one of the ways they started monitoring is through rain gauges and also other instruments, either at home or in schools. Yeah, And that's where I reached to schools. So now we call them like either climate aware schools or climate equipped schools. So one thing about Kerala, you might know, maybe in Maharashtra also, in Kerala, it's claimed that every 1 kilometer or 3 kilometer you have a school. It's a very literate place. And if you can equip each of these schools across Kerala with a rain measuring instrument, which is like they have shown, it's quite easy, very cheap. So if you can spread it across, you can accurately, or to some extent, you can see the variations in rainfall and also go about any activities based on that. Now, that is how we started working with schools. You can see one of the schools, it's in one of the, it's in the Western Ghats region. So in Kerala, there is, you have the Western Ghats with the hilly areas. We call it a high range, then the mid range and the low range towards the sea. Yeah. So this river, Minichal River, is like 80-kilometer river, starts from the high range to mid range to low range. And when you have heavy rainfall events in the high range, it goes through the river, and you can say at what lead time the river swells in the mid range or down the flow, downstream. Yeah? And that is exactly what this story talks about. They started documenting this. Yeah. So until you document, you have a hint. You have a hint that okay, there is some connection with the rain and the river. So this is what I was connecting between the rain thing, which these people were doing, and the river thing here. Yeah. So a lot of water security issues, flash floods or droughts in this region, maybe in Maharashtra also, are linked to 3 minutes left already. Yeah, perfect, fine. Yeah, are already linked to the changes in the river systems around. Yeah. So what they did was they started monitoring the rain, but also started monitoring the river using river scales in whatever ways they could do. Yeah. And you can see one of the logbooks here with the children, where the children had noted down. And this shows on 17 October 2021, 190 millimeter per day. In some regions, it was about 300 millimeter per day. Similar events occurred over Maharashtra also. You can see this big spot leading to landslides in the recent period. 1,000 millimeters of rain in 2 days. So these kind of events leads to landslides, leads to flash floods. Yeah. In 2018, the major Kerala floods, yeah, these people were able to inform the people downstream that in 3-4 hours, so there was a colony of 60 families that in 3-4 hours, this area is going to be flooded because heavy rains have happened in the upstream. Yeah, but these people were not, the colony people were not ready to move out because river was dry, it was not swelling. But with persuasion, along with the showing the data, yeah, finally they were moved, and in 2-3 hours, the area was wiped out with water. Yeah. So lives of 70 families were saved in that, just because of that citizen science network. Yeah. Now, why it is quite important, the reach of metro agencies like IMD is maximum to a district level, or it's a national agency. Its scope is it may not cover beyond districts and so on at a granular level. That's where this collective action from citizens and experts, where they have come together and started collecting data, have helped in saving lives and livelihoods as well. Now, yeah. So these challenges are going to amplify in the future, which means that we need more of these kind of examples set across the country or even South Asia. This is a perfect example where, you know, connection between rain, river, and the entire region, yeah, can, especially with data, can help. Now, these people are trying to make a model using these rainfall measurements and the relationship with the river water flow. So it's based on artificial intelligence and machine learning methods. So you get the data through that and see, make a model. So without depending on your assumptions, you can tell at what lead time the water will rise in a particular region. Yeah. So that is where we have reached. And this is being, I know that time is over, just 1 minute. So this is where we are scaling it up, connecting with colleges. So I told you about the 80-kilometer river. So there are many schools around, right? There are many colleges also around. So these colleges are taking up this data. They have their own rain gauge networks and other instruments as well. So they analyze and they put it up on the web. There is a Jal Chetna portal looking at with the maps and all, like what Bhavdar was showing. So there are multiple colleges doing that. They have their reference sites as well. And this they then, this information they send to people like me at institute or university level, where research can be done based on this, yeah, on understanding the hotspots of extreme rainfall and all. So basically, you can connect this all. So there is one point that I would like to make. So many of the presentations that I saw earlier, it showed like, okay, even Mathew was talking about, okay, this is more on interest level or hobby level. So we have not gone into publication. I mean, I'm not talking about particular activity, but I saw that many of them have not gone into publication. But I feel that by communicating it on a regular basis, you don't need to publish in major reports or journals, but just through newspaper media, you can push the policymakers so that they make relevant changes in policy and so on. Yeah, I think that's it. Thank you.
Thanks, Roxy. So
Yeah.
we have time for 2 or 3 questions.
That's it.
Hi Roxy,
Hi.
this is Ganesh from the Nature Conservancy. You had given the example of one extreme rainfall village where
Yeah.
the lives of 70 people
Yeah.
are saved. I just want to know, based on the data, how that action is decided, how how that thing is conserved, how the
Right,
data is converted into and decision is taken to convert that data into action,
Exactly.
and how the peoples have. Are people decided by their own, or like some expert have given some guidance on that?
Right,
Thank
right.
you.
So that action which they took on 2018 was totally based on that small group of volunteers. Yeah. So they saw that, okay, rainfall has happened, and it's based on mostly assumptions. Yeah. They had the data of rainfall, but they didn't have the, how to connect to the, exactly to the river flow and floods and all. But they assumed that this will happen. Yeah. But now there are attempts to, make it all numerical, model based and all, because right now we have that data. So attempts are going on. Yeah. So until now, we cannot say we have a system, foolproof system to, without failure, you can do the alerts. Yeah, exactly. And all this information goes regularly to newspapers. So they are giving the daily rainfall and the daily river scale to the newspapers. Newspapers are publishing. They have a small column on a daily basis during the monsoon period, which is quite effective actually.
So this is just something which came in my mind, that rainfall data is something for the monsoon period, but what about humidity data across the year? Is there a simple way to measure it locally? I know something called hair hygrometer, which even kids can make, but will it give some reliable data? Because just as flooding, etc., is a problem, forest fires is also becoming a problem in many areas, and that is linked with dry summers.
Yeah.
So can we do some citizen science around annual or daily humidity measurements?
Humidity is one of the most uncertain parameters, even in meteorological sensors. Even with satellites or even with hygrometers, we find a lot of difficulty, because even between standardized hygrometers, we see a lot of difference. It's a challenge even for us. I think maybe we can have maybe along with, but you are asking about for very simple techniques or instruments. I don't have in mind right now other than standard. Yeah, Brian.
We have one.
For how long the data is collected? It's been how many years now?
So it started. It started with a few. So in 2017 it started. So now 5+ years. Yeah. This one of the schools. This school with the log, maybe 3 years now. Yeah. They published a book also, small book just with the data. No analysis, nothing but daily data. It's beautiful actually.
Yeah. Thanks, Roxy. So any further questions we can always take offline.